We talked about this yesterday. We're going to talk about it again. So this, yesterday I told you it's called vertex form. We didn't exactly talk about why. We are on like the third page, I think it is, the top of the third page. This, it's already on there, but I changed it a little bit. It's on there. I changed it a little bit. I'm actually changing it, hopefully, to make it even easier for you. So what you probably want to do is.
He's not in there, put it on the table. I see it through the door.
Will you see it along with my card? Is his door unlocked?
He's outside. Yeah, he locked it.
Which outside?
Like out in the park.
Yeah, like that way, not in the courtyard. Okay. Well, we'll go. It's, is he lunching or is
No, he's doing an assignment. Like we're like,
yeah. But he's not at lunch. Okay. We'll check back later. I have keys. I don't know if they'll open this one. All right. So this is, like I said, written on there, but you may want to adjust it. So they have that B. See that B? You see where the B is? Okay. Now the reason I'm suggesting you adjust it is because this B has to have those extra parentheses there. You see how I have an extra set of parentheses in here where the x minus h is by itself and then the B is kind of by itself. If it doesn't look like this, you have to make the equation look like this. And I'll write that down in a moment, what it just said. But I'm telling you that now because I put that in your homework. And so if you're working ahead on your homework and you didn't know this, you're going to get one wrong. So that B has to be outside of parentheses. So let's start and let's go through each of these. A, what does that stand for in transformation? Vertical stretch. Shrink. Or reflect in the x-axis. So then the B value is what? Yes, I'll write that last. What else? Horizontal, stretch, shrink, or reflect in the y. So what I'm saying is it has to be factored out of the translation. Has to be taken out of the translation. Has to be factored out of that translation. You're going to have that extra set of parentheses there. The only thing that they didn't write it down, and I think that it makes it a little bit more challenging, because then you just have to remember it, so let's just write it down. So has to be factored out of the translation. Did everybody have enough time to write that down? Because I got to scroll back up. So then H. What's H? Translate. If we're doing it horizontally, what are my options? Left or right? And then our favorite, translate, where? Up or down. So that is a summary of every That's a summary of every single transformation that you're going to do in the ever. For real though, this one has to do with squared. All of the transformations are the same if we did cubed, or all the transformations are the same if we graph a square root function, which we will someday. All the transformations are going to be the same when we graph trigonometric functions, which we will. All the transformations are the same if we graph rationalized or rational functions, or another fun name. Exponential. Yeah, he's not like new. He came from another teacher. Will's gone, we're going to replace him. Yeah, it's not like new. He's just coming from another teacher. But we think he went to lunch. Alright, so then this is vertex form. And what's great about vertex form, the reason why we call it vertex form, is because in this form, the horizontal transformation and the vertical translation and the vertical translation, the h and the k, it says it right here, is the vertex. So if you look at that equation, you could say, oh, the vertex is at hk, whatever those numbers are. If you know it goes to the left 1 and down 3, then you know the vertex is at -1, -3. Easy. Okay. Now we're going to be writing equations today. And we're going to start out easy. We're going to do a challenge one. Warning you ahead of time. Example 3. Writing a transformed quadratic function. Let the graph G be a vertical stretch by factor 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of f of x equals x squared. We're going to write a rule and we're going to identify the vertex. So right here, we've done this before. When we see followed by, that's when I want to say simplify. You see the word followed by, you're going to stop and you're going to pause, and you're going to simplify whatever you have before you move on. So we're going to do this in 2 parts. We're going to start with just the vertical stretch factor 2 and a reflection in the x-axis. That's my halfway equation. That's h of x. Or n of x, if that's how you make your equation. Or you agree with me. So we're going to start with h of x. I'm going to do this in function notation first, like with f of x and h of x, and then we'll actually use the equation second. So h of x, my halfway equation, is a vertical stretch factor 2 and a reflection in the x-axis. Vertical stretch is vertical, reflection in the x-axis. Is that vertical or horizontal? They're both vertical, so they both go on the outside. They're also both multiplication, so we're going to multiply -2 by whatever our function is. We're going to take -2 and multiply by our f of x function. So we go and we read our equation. What is our f of x function? Okay, so h of x is taking -2 and multiplying it by x squared. Then it says simplify. All right, well, -2 times x squared is -2x squared. That was an easy simplify. Sometimes they're harder. More challenging. Now we're going to do the second part, g of x. So it says translation 3 units down. So I'm going to use my previous function, which is h of x, and translation 3 units down goes on the outside. It's vertical, so it keeps its same sign, -3. So what is my h of x equation? -2x squared -3. Hi, dear. Nobody told you we don't eat a lunch, did they?
Oh, no.
I know. I started emailing saying, we need to find you. Come on in.
So what lunch do I have now?
We'll probably put him here, but you can stay there. Will you sit here today?
Nothing.
Is that okay? Do you have a graphing calculator?
Yeah.
Okay, you can stay there. Let's call some sharing. sit there normally, but they're sharing a calculator for a moment. That's why I'm speaking up. And then we are doing some notes, which you probably have already done this stuff, but I don't know if you use the exact same notes, so you just catch on where we are. We are. Alright guys, can I actually subtract these? No. So then I'm done. Yay! Well, except for I do have to find the vertex though. Vertex. So the vertex is our horizontal translation, comma, vertical translation. So we look at this equation. In this equation, our horizontal translation would be inside of parentheses with the x. What's being done horizontally to this x inside parentheses? No, that's outside. That is vertical. Nothing, right. Yeah. And then our vertical translation is outside, so that's what? -3. There you go. We have our vertex. You are -3. Now, the next example is the next teacher example. We're going to skip that and go to the first student practice, which I don't know what number it is on there. It's number 7. So please look at the correct one. I want you to use the one we just did together, and I want you to try student practice number 7 by yourself, and then I'm going to walk around and we'll go over it. I'm going to put up the one we were just working on together since he just walked in and he didn't get to see all the work. But we're doing student practice number 7. Does everybody know what we're doing? If you try that teacher example, you're going to, like, not be happy with me right now. So try that on your own. I'm going to come around and check your answers. I have a special pen that puts smile faces on correct answers, so really cool. And you can also ask them questions. Since it's student practice, but like, it's not a test or anything. So you're doing the equation and a vertex. See, special pen, huh? Pretty cool pen. Maybe you want to snap it on it. If you'd like to read the next teacher example, go for it. Don't get scared though. We're going to do that first. Yeah, the equation, you can write your own vertex. I like that special pen. And it's so cool how there's smile faces on the paper. So do we don't find your answer? Okay.
I just don't like moving my pencil around. It's like, wow, it's not.
Just need to write your vertex.
Wait, so you, I know that
You should have paid attention.
I was thinking she's gonna.
I don't like to answer silly questions when you could have just figured it out.
I thought it was gonna be like a pen with like a smile face.
You gotta find your vertex. You gotta find your vertex. Yeah. Right here. Yeah, so don't do that one yet. This is the next teacher example. We're gonna do this one. Yeah, just read them. It was there 2 seconds ago. Your brain? Well, I don't know. You know what? From it almost to me, I'm getting old, it almost to me like blends in here. The fact that you squared in that answer and I didn't see another squared in answer kind of made me just like convince myself you hadn't done something yet. Plus she hadn't done it either. Ooh, that does not look like an ordered pair. Oh, it's an ordered pair, okay.
I can't do.
Hello. Yeah. She did. Can she come get it? Okay. Yep. Alright. Bye.
I left my car keys and everything in there.
Good. Alright, who's gonna get their smile face yet? You got yours straight. Right.
This is where you guys
Yeah. Not quite yet there.
The first
Erase that. This is almost right, but not even that's right yet. So we're going to do example 4 first. Oh yeah, you don't need for that. No, you don't need to. So that's not right. So erase. We're going to do this together. Ready?
I know. I walk in there and they go, "You sprinted, didn't you?" I thought you were around the corner.
He's around the corner also. He's not that far. Okay. I forgot I'm recording this whole thing. So really fast, if you didn't get done, h of x is the first part. That's the vertical shrink factor of a half. So we do 1/2 of f of x. So then h of x is 1/2 of x squared. And then there's nothing really to simplify there. Then we do our second part, g of x. We're doing translate 2 units up. So I'm going to take my h of x and add 2. So g of x is going to be my 1/2 x squared plus 2, and I look at that, and that's already simplified. So we have our equation, and then our vertex is our horizontal translation, which we didn't have any, comma, our vertical translation, 2. And yes, order pairs always get written in parentheses, or you miss a point per question that you do that. So, 1 minute. So now we're going to do example 4. Write small. Maybe start over here in the margin. Just telling you, because yesterday they were all like, I ran out of space. Okay. I'm telling you ahead of time. Write small. Let G be the graph of translation, 3 units right and 2 units up, and then there's my followed by simplified part. And then we have, second part, a reflection in the x-axis. So we will start with h of x. H of x says, translate 3 units right and 2 units up. 2 transformations, one is horizontal, one is vertical. Horizontal goes inside of the function. So we do whatever our function is. 3 units right is going to be x what? Minus 3, we do the opposite. And then outside of the function, plus 2. Now what does f of x minus 3 mean? Means replace x with x minus 3. Wherever you see an x, replace x with x minus 3. In the function, wherever you see an x, replace x with x minus 3. We go to find our function. Here it is right here. I see more than one x. So every time I see an x, I'm going to replace that x with x minus 3. Every time. So I've got h of x. Then I've got x squared. So now I'm going to make it x minus 3 squared minus 5. And then there's another x minus 3. But after I do that, what's the plus 2 mean? No, what's plus 2 mean? What's that mean? Well, what's that mean for my equation? What do I do? You just add it on the end, plus 2. That's what that means. Add it to the outside of whatever you already did. So you see how I had to put that in 2 spots. So then our next part of the instructions, followed by, means, so this, I'm going to simplify, meaning I'm going to get rid of all these parentheses and combine any like terms I possibly can. So last class we went over things like x minus 3 squared. How do I multiply x minus 3 squared?
Foil.
Yeah. Before I FOIL, I gotta do something first.
X minus 3 times x minus 3.
Perfect. X minus 3 times x minus 3. So then I'm going to, you can use the box method, you can use the FOIL method. You can think of it just being distributive property. I'm going to do x times x times minus 3. And then I'm going to distribute the negative 3 to the x and the negative 3 to the negative 3. Then I'm going to add those up, combine like terms. Those are to write small, right?
We're gonna have to use like the FOIL thing like when it comes to doing series too.
Yeah.
What would be the best way to do that? It seems like that would just get confusing.
We'll do it. We're not going to do it today. I'll show you when we get there. But if you're talking about like there's a cube out here,
Yeah.
you would have to do 2 of them together, find that answer, and then take that answer times the third one. So you're doing the box method, right?
Yeah.
So you'd have like a 2 by 3 box
Yeah.
for the second part of it. Yeah. Okay, so now I'm going to get rid of the parentheses here in the middle where there's a minus 5 in front. How am I going to get rid of that? Distribute the minus 5. Make sure that minus is part of it, so we get minus 5x, and then plus 15. Then I'm going to bring it down, minus 5x, plus 15. And then that plus 2 on the end, it's still on the end, plus 2. Yeah. And then we haven't done so much of talking about what terms are and like terms and combining like terms from previous course. You combine like terms, but like terms have the same variable, same exponent. So does x squared have any like terms? We'll have h of x equals x squared. And then how about minus 6x? Minus 5x, so minus 6 minus 5. Minus 11x. How about 9 and 15 and 2? 26. Is there anything else we can simplify?
No.
All right, we're halfway done.
And then you graph it with standard form?
Are we graphing this?
No.
What's the h of x? That's like our halfway done equation. What do we do now? G of x. So now we're going to do g of x. And g of x is a reflect in the what? Y? Is it what? Yeah, in the y-axis. So that is a horizontal. So we're going to take our h of x, but do h of negative x because it goes on the inside because it's horizontal. So what does that mean? Replace any x we see with negative x. Any x we're going to replace with negative x in our h equation. So here's my first x. So I'll do negative x squared minus 11 times negative x plus 26. And that's really bothering me, so I'm going to simplify it. It's bothering me that there's these parentheses there. So if I simplify negative x squared, if I do negative x times negative x, I get negative times negative, positive x squared. And if I do negative 11 times negative x, positive 11x, so plus 11x. And then 26 is still just 26. Yay, done. This one does not say find the vertex. Yay, done. It's not in vertex form either. We'll probably find the vertex though. Vertical shrink.
It should be 0.2.
No, that's the, oh maybe.
So you need the-
Yeah, no. It's a translation 2 units up. So, oh wait, no, I'm looking at the wrong one. I'm reading over her shoulder and showing me look at the wrong one. It's 3 to the right, 2 up. So wouldn't the vertex be at 3, on the 3, 2? Oh no, because then it's reflecting over the y-axis. So it'd be a negative 3, negative 2. I think so. That's okay. We're not finding that one. All right, guys. So now, you try. All right. Let's see if you can do it. I'm gonna pause the video this time. Hey, do you have questions on this one that you were doing by yourself? All right, so we're going to do this graphing calculator example. That's the last example we're going to do today. So go ahead and flip your page over when you're ready. So you got your graphing calculator. Read the equation, or read the problem. Yeah. What is it, example 5? Sorry, you said? Yeah, example 5. Read it.
The height h in feet of water spraying from a fire hose can be modeled by hs equals negative 0.03 x squared plus x plus 25, where x is the horizontal distance in feet from the fire truck. The crew raises the ladder so that the water hits the ground 10 feet farther from the fire truck. Write a function that models any path of the water.
Perfect, thanks. It's up to you. Thank you. Don't be jealous of my amazing skills though. Okay, so what's happening is there's first the fire truck is spraying water onto the ground, when you spray water, does it just make a straight line? No. What's it look like? Quadratic, a parabola, yeah. There you go. Then what happens is they raise up the ladder, so then we're spraying higher. Still the same function, it's just now we're spraying higher. So because we're spraying higher, now, the water is going to land further away. So how far away is it going to be landing? 10 feet. So what I want you to do is we're going to go ahead and graph this equation, the equation right here. We're going to graph it on our graphing calculator because that's one that we really can't look at and see transformations. It's in what's called standard form, it's not in the vertex form. So go ahead and plug it into y equals on your graphing calculator. Now, I'm guessing some of you are going to have some issues because we were doing statistics before, and some of you had issues switching before, back and forth. So I will help you fix your calculator from where we were using it before. So you go to y equals to type in your equation. If you have anything on this y equals screen, like another equation, it's cleared out. But also at the top here, you see how it says plot 1 and it's dark? If you have that turned on, then what you're telling your calculator is, I would like to do a scatter plot. And are we trying to do a scatter plot right now? To turn the scatter plot back off, or turn it on again, or off again, you can just take your arrow up and hit enter, and go back down, and then the scatter plot's off. So make sure it's off. What's the middle term? Who's got it? Is it plus x? You have it in front of you. Plus x plus 25. Thank you. Mine's almost the same. Oh yeah, it is, but we're going to fix something else. I know it's wrong. So now, some of you may say, it's not working, I don't see it. And my question is going to be for you, what is your window?
I'm confused on just how to get the X because there's
Yeah. And then the X word, there you go.
okay.
So if you hit graph and you don't see it, I bet your window is not set up to see it. I want to show you how to fix the window fast. And then we already went over how to change the window to anything you want. So we're going to do that as well. But I want to show you how to just fix the window really fast. Okay? There's this zoom button on the inside middle. Did you get it typed in? Okay. Zoom, when you click on that, there's different windows that we can actually choose. And choosing zoom 6, you just hit 6. Zoom 6 is a standard window that's -10 to +10, -10 to +10 for your X's and your Y's. So if you hit zoom 6, it'll always take you back to that nice window that I always give you on your graphs and your worksheets to use as well. So you hit zoom 6, it looks like that. And then you say, but I don't see a graph. No. What is that last number in the equation of the graph? I bet you that graph is there, and it's just not showing between -10 and +10. Because that number in it was a 25. I bet it's somewhere in there. So I want to show you something else you can do. And I haven't showed you yet. There is a table that you can get to. You do second graph. And under second graph are all the ordered pairs you'd ever want to know about this graph. Now, mine starts at 60. Yours probably starts at something else. I'm going to show you how to make it start at whatever you want it to start at. Okay? You can adjust your table really fast. You can scroll up or scroll down. You can do that. But if I'm at 60 and I want to go to 0, it's going to take me all day. So I'm going to use what's called table set. You see table set, second window. And this first thing says, where would you like your table to start? So start wherever you want. And then this little triangle means change. What do you want your numbers to go up by on your table? So you can go up by 0.5s if you want. You can go up by 1s. You can go up by 20s if you want. You can go up by anything you want on the table. I usually use 1. And then go back to your table. And now mine has jumped to 0. So you can see that my y-intercept is at 0.25, which is why we couldn't see it on the graph. So maybe we zoom out on our graph. Maybe we change our window. Let's go to our window. I'm not going to need any negative x's because the x is horizontal feet. And that's not going to be negative in real life, so I'll do 0. And I want the y's to go from 0 to, I have no idea, 25, so maybe 50. Maybe 0 to 50, maybe. Just kind of guessing.
Should you put the minute?
Yeah, thank you. You know what? I did that in my last class as well. And everybody just went with it, and they all did the exact same thing I did. Sorry. Thank you for saying that. Put it as a math something in. Okay, so once you have that, hit graph, and do we see the graph yet? We do, part of it. So what I'm missing about this graph and what I drew on my picture is I'm missing where the water hits the ground. So it looks like I need my graph to go further out. And maybe I don't want to sit here and just play the guessing game of how far out it needs to go. Maybe I go back to my table. And maybe I look at my y values and watch my y values until they get to what number will it be when it hits the x-axis. What number will my y be? Yeah, let's look until we get to y. I mean 0. Y equals 0. There it is at 50.
Mine
So-
is the opposite way. Like, I have to scroll up and then it goes down. Maybe scroll
Yeah,
down.
but we're not using negatives.
It started on 0.
Yeah, but then you went up, and you know what? It does get smaller both ways. Because look at me, the parabola is going smaller both ways. But we want to go positive. Your graph looks the same as mine-ish, didn't it?
Well, when my x's increase, so do my y's. Aren't the y's supposed to get smaller?
At some point they will. The water's doing this. Hey, Finley. The water's going like this.
Yeah, I know, but that's not, for mine it just keeps going up. Like I'm at 45 and it's at 130.
Okay, go y equals, you typed it in wrong.
0.03x squared.
Negative 0.0. Do you know how to insert so you don't have to retype the whole thing? I'll come show you. Okay guys, go back to your window. I'll come show you. Go back to your window and maybe make our y maximum or our x maximum be what? Bigger than 50. Give me a number.
52.
So it's at 50 and we want it to go 10 bigger. So we want it to go to 60. So do you second it, and then there's an I and it says insert, and you just hit the negative button, and then you don't retype it. Then you need to graph for table and stuff. All right, now I want you to go back to your table, and what I want you to do is find what is the y value when x ends up being 60. So I'm adding 10 more feet on to the 50. I'm adding 10 more feet on. So find the value of y when x is 60. So what I did was x was 50 when it was hitting the ground. I'll put it on my picture. This was here. This was x was 50. And we need to add 10 feet on so that x will now be 60. That's what we need to happen. So what I'm doing is I'm trying to find in the original equation where is x 60, what is y? And what'd you guys get? 60 comma what? Negative 23. So what I need this graph to do is I need it to move up 23 spots, and then this will be at 60, 0. I need this to move straight up 23 spots. So if I take my equation, negative 0.03 x squared plus x plus 25, how can I make this equation go up 23? Plus 23 at the end. What does that make when we combine like terms? So what I want you to go back to y equals and type in a second equation. This is our new equation, plus 48 at the end. Same first two terms, just plus 48 at the end. Oh, look. Now it does look to me that it's hitting at 60, but we can be sure by looking at our table. So we go back to our table. Now you're going to see your y1 and your y2. So if I go to 60 on the x, look at my second equation now. It's hitting at 0 for the y. So then we can confirm it. All right? I love the table. The table's helpful. How can I jump back to the, like if I want to know where x is 0, how can I jump to that on the table? So I don't have to scroll. Table set, right? Second, and then table set. And I could just type in 0. Or you can type in whatever, wherever you want to go in the table. Okay? That's all for our notes. We have an assignment that is in the book. The book assignment is on the stuff that we did, on the, like the notes, and then you have that 4-question review, which a lot of you have been working on throughout class as well. All right, if you need a book, I've got some of them around the room. If you'd like to check out a book, grab a book and come see me. If you'd like to check out a book, grab a book and come see me. Okay? If we use all the books that are around the room, I still have more in my cabinet.